For years, the quantum computing industry has had a credibility issue, hiding quietly just beneath its own marketing. Nearly every company in the space publishes its own roadmap, measured by its own chosen benchmarks, and verified almost entirely by the company itself. When a lab gets to design the test and announce the results, the numbers become incredibly difficult to trust. Looking at this diagram, you can see how impossible it is to compare progress. One company might emphasize a rapidly growing physical qubit count on the left, while a competitor highlights exceptionally low error rates per operation on the right. Both claims can be completely true, but they tell you nothing about which machine is actually closer to being useful. Without a unified standard, an investor or a taxpayer has no reliable way to tell a genuine technical breakthrough from a very expensive science experiment. To cut through that noise, the Pentagon's research arm, DARPA, has stepped in to run a rigorous, independently verified evaluation process. It's called the Quantum Benchmarking Initiative, and it exists to answer one specific, unforgiving question: can a company actually reach what DARPA calls utility scale? In this visual equation, utility scale is defined as the exact point where a quantum machine's computational value clearly exceeds what it costs to construct and operate that massive physical infrastructure. That economic framing is deliberately unglamorous. It strips away the marketing language and forces every competing company to answer the exact practical question a defense planner would actually care about. The program moves in stages, and each one gets progressively harder. Stage A functioned as an initial filter, where 15 different companies were required to prove they had a genuinely plausible path toward that utility scale. From that initial group, the field was filtered down to 11 survivors. Several established, well-funded names simply did not make the cut. The 11 remaining companies have now entered Stage B, a year-long deep dive where DARPA evaluators pick apart their full research plans. They aren't looking for broad concepts anymore. They are hunting specifically for the technical risks hiding inside the architecture and demanding a strategy to mitigate every single one. The final hurdle is Stage C. Two companies, Microsoft and PsiQuantum, have already reached this phase, where they face a full-scale adversarial government testing of their physical hardware and individual components. Watching major industry names fail to advance sends a clear signal. Prior investment and name recognition cannot protect a company from this specific brand of scrutiny. Evaluating these companies fairly is difficult because, unlike classical computing, which settled on silicon chips decades ago, quantum computing currently has no consensus architecture. Rather than guessing which approach will eventually win out, DARPA is deliberately pursuing a portfolio strategy, testing the strongest contenders across multiple physical approaches simultaneously. The sheer physical diversity of the machines is staggering. You have IBM building deeply established superconducting circuits, cooled close to absolute zero, competing directly against Xanadu using room temperature photons of light, or atom computing relying on laser-trapped neutral atoms. By funding these diverse modalities all at once, the Pentagon is effectively running a controlled, independently verified experiment across the entire technological landscape. All of this testing is racing toward a very specific finish line: the year 2033. The primary hurdle standing in the way of that deadline is achieving fault tolerance. Individual qubits are extraordinarily fragile. Getting enough of them to reliably correct their own internal errors at scale is a challenge researchers have been chasing for decades. DARPA's own documentation directly acknowledges that solving this engineering challenge could approach or even exceed the complexity of building a classical supercomputer. Because of that complexity, the agency is remaining deliberately open to a very real possibility that no single company manages to solve this problem before the deadline hits. Giving the industry roughly 8 years to figure it out applies a structured, disciplined pressure to a field historically driven by vague, distant promises and endless hype. The immediate consequence of the program is that for the very first time, the entire industry is being forced to operate under a single, verified, apples-to-apples baseline. Serious investors and defense planners deciding where billions of dollars in strategic funding go will now lean heavily on this rigorous standard, rather than trying to parse flashy corporate metrics. It is a reminder that genuinely useful technologies are rarely proven through press releases. They are proven through patient, unglamorous, third-party grinding year after year. Whether one of these 11 companies delivers a fully functional machine by 2033, or they all fall short, DARPA's test has forced reality to finally take over.